Hello and welcome to this segment of Introduction to Autonomous Systems. In the last segment, we had introduced the Bayes theorem and also update using Jeffreys conditionalization and came to a conclusion that while having a few limitations, Bayes approach still works reasonably well in the context of practical scenarios. Let us now take this idea forward and introduce the essential probability related practical tools such as betting and odds. I am sure all of us have heard these terms in different contexts. What we will try to do is we will try and understand this ultimately and relate it to our whole philosophy of designing intelligent rational agent. As you realize, betting and odds are commonly employed terms in any game of chance, and the idea essentially of using these is to better understand the implications of probability associated with uncertain events. It essentially to improve our understanding of the probabilities and their implications. Now, let us assume that probability is a direct result of gambling related uncertain scenarios, and based on that, if we introduce the concepts of betting and odds, now what we can do is, because the probabilities that we are using in our intelligent rational agent designs in some way are related to uncertain events, we can bring in these concepts of betting and odds in our attempt to arrive at a decision through uncertain reasoning. So, this becomes now the foundation for our uncertain reasoning that we have to do in the context of intelligent rational agent. So, let us first define what we mean by odds. So, odds are typically defined as the ratio between the cost of a bet in favor of a proposition and the reward should the bet be won. This is indirectly saying that what are the chances that a proposition which I am making will come true. So, a hypothesis which is the proposition being true, and if it becomes true, then the reward is the correct action that one has taken. So, let us explain this idea from a very simple point of view. Let us say that we have put a stake of rupees 100 on a bet or a hypothesis at the odds given by 1 to 19. Let us say these are the odds which are offered for that particular event or a hypothesis being true. So, if we now kind of analyze this particular scenario further, we find that there is a cost of rupees 100 involved in this bet, but you will get rupees 2000 including the cost of bet if the bet is won or the hypothesis comes true, which means that the actual reward is only 1900, and that is how the odds are set. Odds are ratio of the cost of bet and the reward. So, in this case the cost of bet is 100, the reward is 1900. So, the odds are 1 to 19. Now, let us say that these are the odds. What do they mean about the probability of that event coming true? Because ultimately that is what we are interested in, because from all our Bayes theorem we will end up with getting a probability, and if we can convert that probability into the odds, then that tells us that if we kind of choose a particular hypothesis, what are the rewards if it comes true, but what are the kind of penalties if it does not come true. Now, if we were to understand the odds a little more, they are generally set at any ratio. So, now there is a possibility that in a realistic scenario where in any game when you are doing a betting, the odds may not necessarily have to do anything with actual probabilities. Let us understand this idea a little more before coming to our intelligent rational agent and what we should be doing in that scenario. And normally most of these bookies who give odds for various scenarios, they are for hypothesis being true as well as not true, or what they call for and against a hypothesis, which means the odds are given for H as well as negation of H, and this is where the issue comes with the odds in the general scenarios that we normally encounter, and because they are marginally different. And the implication is that bookies will make money irrespective of whether the hypothesis comes true or it does not come true, which means under any condition the bookie makes money. And that is the reason why the odds for victory and odds for defeat are adjusted such that no matter what happens, the bookie always wins. Now, this obviously is not doing the right thing, and right from the beginning we have been saying that our intelligent rational agent is required to do the right thing, which means now we need to get an idea of what is called fair odds, which means that your odds in favor and odds against have to be consistent with each other, so that there is neither profit nor loss depending on the hypothesis being true or not true. And this also brings in the idea that the fair odds bring in the interchangeability of odds in favor and against. Typically they are defined always in favor, and it is nothing but the ratio of a hypothesis being true with respect to it being not true. So, that is how we put the fair odd philosophy. So, there is what is known as a odds probability relation as follows. So, we define odd about a hypothesis H being true as the probability of H being true divided by probability of H not being true, which in our opinion is 1 minus pH, so that if you add these two it adds up to 1 and it follows the laws of probability calculus. Of course, we can now do some amount of algebraic manipulation and we can show that the probability of a hypothesis being true can be shown to be ratio of the odds in favor divided by 1 plus odds in favor of hypothesis. So, this is the connection between the odds and probability. So, if you have a probability from a particular event using the Bayes theorem, you can convert it to odds. If somebody has given you odds for an hypothesis being true, you can find out what is the probability of that event being true. So, these are interchangeable. Now, let us go back and write down that Bayes theorem in terms of odds instead of probabilities, and now we are talking about fair odds. So, the same theorem in terms of odds is that odds in favor of hypothesis H conditional upon evidence E is same as the odds of that particular hypothesis being true prior to this evidence and the likelihood ratio. which is the probability of the evidence being connected to hypothesis being true and the probability of evidence being connected to the hypothesis not being true. Next, let us now bring in an idea which we had discussed quite some time back, but now let us see if we can formulate that in the context of Bayesian reasoning, and that concept is the utility based agent or the concept of utility that we had introduced when we were discussing the agent architecture. The utility, if we look at it in a very loose sense, refers to usefulness or lack of it, whichever way it could be, in carrying out any activity as perceived by us. In fact, as humans, we always have this fact in mind whenever any activity or action is done, that what is the usefulness or utility of it? Does it bring any reward? In fact, as humans, we generally know what we like, we also know what we do not like, and there is a thought in between which says that we are experiencing neither of these two sentiments, which means sometimes we say chalta hai, which means we are not for it, we are not against it, if it happens fine, if it does not happen fine. So, we have these three broad bins, qualitative bins, where our interpretation of usefulness or lack of it lies. So, this idea was taken further by Frank Ramsey in 1931 in the form of a utility function, which says that a utility function essentially is a combination of particular utilities subject to the condition that we have an ability to order bets with definitive probabilities, which means the moment there are bets, there are odds, convert odds to probabilities, and if you can order the probabilities in a particular manner, then you can define a utility function which directly talks about the value that a particular hypothesis will bring. So, what it says is that if we have a utility function u over every possible outcome of a particular action A, for example, you take an action, there are 5 different outcomes. All the 5 outcomes have certain probabilities. Some of them are desirable outcomes, some of them are undesirable outcomes. You now put all of them together in the form of a mathematical relation is defined as I have shown here. Sum of product of utilities of a particular ith outcome multiplied by the probability of that ith outcome. Now, as you realize that the outcomes could be both beneficial or they could be detrimental, and you will realize that by doing this you will get a number which will be a reasonable indicator of what is the ultimately overall average utility of that particular action, and that will help you take a decision whether that action should be taken or not taken. For example, if A is an action which has lot more detrimental effects, then using this particular, even if it may have 1 or 2 benefits, but if it has large number of disadvantages, you actually may not take that action. On the other hand, if there are a large number of benefic outcomes and maybe a few drawbacks, this particular quantitative measure of that particular action would tell you whether that action should be taken or not, and it is an important aid in our decision making process. And you can clearly see that this expected utility is an average of all utility functions weighted by their respective probabilities, and this is what an intelligent rational agent is expected to maximize. So, ultimately in an uncertain reasoning context, what the intelligent rational agent will do is to come up with this number for several kinds of hypotheses or actions, and for those actions it will generate this function and then pick the one which gives you the best utility, and that becomes possibly the best action that one could take. Let us now probe this idea further, degree of belief versus rational agent, because our whole thought is around a rational agent which is doing the right thing. This function also brings in the focus the requirement of connecting the degree of belief with the rationality property of the agent. See, currently what we have done is that we have connected the rationality to the probability, a quantitative number, and we say that this probability now is connected to a degree of belief from our initial base hypothesis that the probability is nothing but our subjective degree of belief. Now we want to connect degree of belief with the rationality, because this is how we start. We only have a degree of belief. Probability is an intermediate quantitative measure. Finally, our requirement is rationality. So, we are saying, can we connect our degree of belief which leads to a probability and some quantitative tools, can it guarantee the rationality of the agent? Now, we know that a rational agent is expected to do the right thing, but we also need to ensure that degree of belief based decision making is also the right thing to do. How do we know that the degree of belief which I have converted to the probability and I am updating my belief as the more and more evidence come, I only have a belief for which there is a quantitative measure in the form of utility, and if I take a decision based on this, is it the right thing to do? I need to ensure. So, this connection was established again in 1931 through the basic argument of what they call Dutch book, which stated that for subjective degree of beliefs to be rational, they must obey the laws of probability calculus, which means that your probability of all hypotheses, all beliefs which you put in that universe should be 1, and it should follow all the other conditions, conditional probability, conditional independence, conditional dependence, all those ideas which are part of probability calculus. If they are applicable, then the probabilities which have been generated through quantification of subjective degree of belief will be rational, and that is how we go back and then say that the decision making process which is based on degree of belief or subjective degree of belief is also the right thing to do, making the agent rational even under uncertain scenarios. If we look at the role of Bayesian in the AI development, the whole idea of Bayesian reasoning is to help AI builders to come up with artifacts that can perform many interesting and difficult cognitive tasks that humans perform. And in this regard, the concepts of descriptive AI and normative AI are often proposed as strategies to understand the human behavior and reproduce it in artifact of choice. Thus, we see that Bayesian reasoning based procedures employing probability theory and conditionalization theorem are useful for building human like AI systems, which, if you recall, was our original thought that can we create machines that can think like us, act like us. However, there is still a major roadblock that impacts its efficacy and wider acceptance, that is the Bayesian reasoning. And this problem goes back to the inconsistency in the experts. You remember, right, in the beginning we started by saying that human experts are not really consistent, which means there is no guarantee that probability of hypothesis being true and a probability of hypothesis being not true together will be 1. So, unless that happens, the principles of probability calculus are not applicable, and if that does not happen, then obviously your application of Bayesian process to come up with the belief based on which you take a decision may not necessarily remain rational. So, this point has to be kept in mind. This difficulty is somewhat being mitigated through the concepts of what is called the learning Bayesian networks. For example, data minings are such Bayesian networks where you are learning from the experience, and based on that you are trying to get your opinions which are lot more crisper, so that the difference between your interpretation of a hypothesis being true and hypothesis not being true together is not very different from 1. And there is another concept called knowledge engineering, which is being combined with Bayesian network to ultimately do it in the form of learning Bayesian networks. So, these two strategies can help us to create intelligent and rational AI agents that are fairly close to human like in their ability to perform various cognitive tasks. Of course, in the recent times we have already seen that advances in computational power, the implementation of such agents has now become practically feasible, but for that of course we are going to need tools such as search strategies, learning algorithms, which we will talk about in our subsequent sections. So, to conclude this part, concepts of betting, odds, likelihood help us to arrive at good decisions using probability estimates through the basic definition of our utility function, which is nothing but a weighted sum of all outcomes of a particular event, wherein weights are the actual probabilities of all such outcomes. So, with that we come to the end of today's session, and we will continue these ideas further in subsequent segments. So, thank you, bye for now, and see you in the next section.